This is the beginning of class lectures for chapters 1 and 2. There are actually 2 parts to this lecture. This particular part will only focus on hypotheses and variables. Part 2 will focus on descriptives and confidence intervals. Sorry. So let's go ahead and start this particular lecture. So everyone has heard of the word hypothesis. Hypotheses simply spell out each of the anticipated possible outcomes of an experiment. In simplest terms, before we embark on the experiment, we need one hypothesis that states that nothing notable has happened, because sometimes experiments fail. This would be the null hypothesis, our HO that you can see here. So this means that the experiment had a null effect or that nothing notable had happened. Another possibility is that something notable did happen. The experiment worked. Yay! That's what we all want. So we would need an alternate hypothesis that accounts for this, which is H1. So here's an example of hypotheses. So continuing with, let's go ahead and think about an example. My background is education, so let's think of, we're going to use an intervention of Z-math. For instance, there's this new math program that is being implemented at a particular school, so we want to see the effect of Z-math. So for instance, if I would construct the null hypothesis, H0, what we expect, I would say that the null hypothesis states that the experiment produced null results. So basically, the experimental group, the group that received Z-math, and the control group, the group that received regular math instruction, performed the same. Remember, there's no notable effects for the null hypothesis. So essentially, this would mean that Z-math was no more effective than the traditional math lesson. The test would mean that Z-math was no more effective. So H1, the alternative hypothesis, is phrased indicating that the experimental Z-math group outperformed the control group. So hypotheses are typically written in this fashion. So HO, which is our null, Z-math and regular math teaching methods produced equivalent test results. Or we have our H1, that there are notable results to record. We have our Z-math produced higher test results compared with regular teaching methods. So when the results are in, we would then know which hypothesis to reject and which to accept. From there, we can document and then discuss our findings. So, how do we know when we should accept or reject a hypothesis? Now, we're actually going to be doing this more throughout the semester once we look at various statistical tests. But basically, the decision to accept or reject a hypothesis depends on the nature of the test. And of course, the results, the alpha level, which we'll talk more about later in the semester, or the p-value. So let's look at different levels of measure. So selecting the proper statistical test partly depends on the type of variables that are involved. So there are 4 levels of measurement: nominal, ordinal, integral, and ratio. Sorry about the typo on ratio, I'll have to fix that. So first we have our nominal variables. Nominal variables are also known as discrete or categorical variables, and they're used to represent categories that cannot be ordered. For example, suppose you wish to code ice cream flavor, and you create a survey, and you're handing out this survey, and everyone has to decide what their preference is. Is it chocolate, strawberry, or vanilla? Well, when you're entering this data, you'll have to use numbers to code each of these. So you can use 1 for chocolate, 2 for strawberry, 3 for vanilla. Since order does not matter among nominal variables, these flavors could have just been as well coded 1 vanilla, 2 chocolate, or 3 strawberry. Nominal variables can be used to represent categorical variables such as gender. You can maybe use 1 for female, 2 for male, or maybe for agreement. If you're saying yes or no, maybe 1 can be yes, 2 can be no. Or maybe for religion, maybe you're asking about someone's religion. 1 can be atheist, 2 Buddhist, 3 Catholic, 4 Hindu, 5 Jewish. Or maybe marital status. 1 could be single, 2 could be married, 3 could be separated, 4 can be divorced, or 5 can be widower. Since the numbers are arbitrarily assigned to labels within a category, it would be inappropriate to perform traditional arithmetic calculations on such numbers. For instance, it would be foolish to compute the average marital status. The same principle applies to other nominal variables such as religion or gender. But there are appropriate statistical operations for processing these nominal variables that we will discuss later in the semester. It's actually chi-square tests, but we're going to talk about that later in the semester. So, right now, I want you to think of nominal variables are considered categorical. Categorical variables. That's what I want you to think. That's what I want you to remember. So, there's also ordinal variables, which are similar to nominal variables. They represent items within a category, whereas nominal variables have no real rank order to them. For instance, remember chocolate, vanilla, strawberry. The values in an ordinal variable can be placed in an order, in a ranked order. For instance, there is an order to educational degrees. If I'm asking for someone's highest level of education, I could say 1 for high school diploma, 2 associate's degree, 3 bachelor's degree, 4 master's degree, or 5 doctorate degree. There is, as you can see, this is ordered. Other examples of ordinal variables could possibly be military rank, or meals, 1 for breakfast, 2 brunch, 3 lunch, 4 dinner, 5 late night snack. But again, I want you to remember, in terms of statistical tests, ordinal variables are considered categorical variables. One thing that you're going to learn later in the semester, the way you figure out which statistical test to use is dependent on the type of variable. First thing you're going to have to think about, is it categorical or is it continuous? So I want you to remember, ordinal variables and nominal variables are categorical, which will lend itself to only certain statistical tests. Okay? There's also interval variables. Interval variables consist of numbers that have equal spacing between them, such as numbers on a number line, ranging from negative infinity to positive infinity. The distance between 1 and 2 is the same as the distance between 2 and 3, which is the same as the distance between 3 and 4, and so on. Some additional examples of interval variables are bank account balance, which could be negative, time, seconds, minutes, hours, days, etc. So interval variables are considered continuous variables. These can be both positive and negative numbers. Now, ratio variables are very similar to interval variables, except that only interval variables can have negative values. Ratio variables cannot be less than 0, so you will not see a negative number for a ratio variable. So some examples include, for instance, weight, distance, income, calories, academic grades. Okay, for instance, F would be, if a grade of F was given, it would be given a weight of 0, D 1, C 2, B would be 3, and A would be 4. Possibly, we can ask possibly the number of pets someone has, the number of siblings, or the number of members in a group. Now remember that ratio variables are also considered continuous variables. So, types of variables will fall under two categories, categorical or continuous. Categorical variables involve assigning a number to an item in a category. The sequence of the category may be irrelevant, such as nominal variables, whereas gender has no inherent order and hence could be coded 1 female, 2 male, or 1 male or 2 female. Ordinal variables are also considered categorical. Unlike nominal, ordinal variables do have an inherent form, which should be preserved in the coding sequence, such as 1 for breakfast, 2 for lunch, 3 for dinner. So we just talked about this. I'm just kind of reviewing it again just to make sure it's a lot of new, could possibly be a lot of new terminology, so we just want to get familiar with these terms. Continuous variables. So continuous variables these are our interval and ratio type variables. Unlike categorical variables, wherein numbers are assigned to represent categories, continuous variables contain values that can stand up to actual arithmetic processing. So these are the kind of numbers that we're accustomed to dealing with. So for instance, consider the variable age. It is possible to compute the average mean age for a list of ages. This is the end of the class lecture for the different types of variables and hypotheses.